Okay, so you're very welcome to Applied Maths Made Easy. Today we're going to be looking at question 2005, question 10b. So as always, you can pause the video, try to get ahead of me when you're doing it, or I can be your stabilizers helping you through the question bit by bit. And the thing is to find your own way. And as I said, we'll be reeling in the years with all these questions. So we've gone from 2001, 2002, 2003, 4, and now today we're looking at 2005, question 10b. A mass of 9 kg is suspended at the lower end of a light vertical rope. Initially, the mass is at rest. The mass is pulled up vertically with initial pull on the rope, 137.2 newtons. So there's your stronger force, right? The pull diminishes uniformly at a rate of 1 Newton for each meter through which the mass is raised. Show that the resultant upward force on the mass when it is x meters above its initial position is this thing, 49 minus x. Okay. Now, when they give you the answer, as I said, you're getting the heads up on where you need to go with the mathematics. So we like those kind of questions, right? And these kind of things, once you sort of go along with it and follow the path of the steps, then it usually unfolds and becomes quite accessible. Okay. Now, so when we're doing it, what you should be writing down now, resultant force is equal to stronger force minus weaker force. Okay, and trying to figure out who and what's what, if you get me, right? So resultant force, do we have the mass of the block or whatever it is, so 9 kg, right? What is the stronger force that is trying to bring it up? What is the weaker force trying to bring it back down? Okay, pull diminishes uniformly at a rate of 1 Newton for every meters through which the mass is raised. Show that the resultant upward force on the mass when it is x meters, 1 Newton for every meter through which the mass is raised, when it is x meters above its initial position, 49. Take away x. Okay, now, so again, hopefully you're getting used to that thing I'm doing. So stronger force minus weaker force. So have a look at this. See, are you making sense of it? Now, the visual representation here, extracting out the maths and meaning and seeing the visual of that story will help no end. Okay, so there's my 9 kg, right? So it has the pull that's bringing it up, and then what's trying to bring it back down, your 9g. Okay, and there's also this pull diminishing uniformly at a rate of 1 Newton for every meter to which the mass is raised. Okay, now again, have a go trying to put down your data and adhering to that template there. Okay, so stronger force, look, so you have your 137.2, what's been taken away from it, right? So since it's 1 Newton for every meter, okay, so what we're doing there then, so I'm taking away your x and I'm taking away the 9g, right? So, and if you look at that, it's not as bad as you think. So when raised by x meters, the pull drops by x times 1 Newton. So, when it was raised by 10 meters, okay? So you get the idea, right? Now, tidying that up, and remember, they're showing you the answer. Fantastic. How many subjects give you the answer? Not too many. Well, applied maths is one of them. Okay, so what you have then is your answer. Tidy that up, and there you go, right? Now, here is our question 10 mantra, right, that needs to be embedded in the DNA of the maths brain. Okay, I can't emphasize how important it is, and you see it lots and lots. Okay, and when if you're struggling with it, the way in would be, right, I need to apply that, and you can kind of go through a sort of a checklist, a troubleshoot checklist to see are you going about it the right way. You get 0 for that. Look, absolutely nothing. But the thing is to give it a go. So you're saying to yourself, right, I'm going to apply this thing, right? So you have your acceleration, so the change in velocity with respect to time. And remember, maths is all about manipulation. So we're opening it up a bit here, unfolding it to take it down another path, right? So imagine the applied maths crossroads, right? So what you're doing then, bottom left-hand corner, top right-hand corner, and off we go. Okay, so your change in distance with respect to time, there's your velocity there. Okay, now find the speed of the mass when it has been raised 15 meters. Find the speed of the mass when it has been raised 15 meters. So see, does that can you figure that out? Okay, now there is an invisible hence, which means that guy there needs to be used. Okay, so see, can you get that equation down? So the hardest thing about it is kicking it off. All right, everybody's fantastic at following the teacher and sort of, yeah, it's grand. Again, when it's you, look, that blank space staring back at you, and that's that sunny day in June, and you're reading the question over and over again. Find the speed of the mass when it has been raised 15 meters. Find the speed of the mass when it has been raised 15 meters. So that can be sort of tough going. So the invisible hence, what you should do, what I'll be doing, write down that. So 9a is equal to 49 minus x. Now we know the acceleration can be represented by something. Well, here's your friend here, right? And see what you're going to do. Are you just going to put down dv dt for a, or are you going to go and put that down? Okay. Read the question again. Find the speed of the mass when it has been raised 15 meters. Right. Give it a go. Now, hopefully you're choosing the right thing. So I see meters mentioned, which should be distance. So let's take it from there then. So we're using your answer there. And if you see what I'm doing there, look. So instead of the acceleration, you have your v dv dx. Okay. So that's 9 multiplied by v. We can do that if you want. So 9 multiplied by v multiplied by that, right? Formerly known as a. Now, so you're on the home straight now. The question in my mind is finished, right? We're on the home straight. So you go into maths mode, go up to 5th or 6th gear in the brain, and all the time when you're doing the question, be half a second behind yourself commentating on what you're doing, because the small maths becomes the big maths when you're taking, you're thinking about other questions inside the exam, right? So it's all about now. Okay, now, so again, tidying it all up, see what I'm doing. Find the speed of the mass when it is raised 15 meters. Well, by the power of integration, look, so see what you're doing, tidying it all up. We're bringing that guy over. So think of it, there's the stopwatch there, tick, 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 tick. So when it's been raised 15 meters, so we're bringing this guy back using integration. The story starts, it's at rest, that's the guy you want. Okay, you see what I'm doing? So, that skill that you'll be learning So important here, look. So you're translating the question, extracting out the maths and the meaning, and then you're getting on with it. All right. So integrate it. So notice that the number there, keep it to the left of the integral, out of the way, but don't forget about it completely. So you integrate it then, add 1 to the power, divide by the resultant power, you have your upper and lower limits, add 1 to the power, divide by the resultant power, you're doing all that. So the integral is gone now. You have your upper and lower limits, so again, I'm putting in a square bracket, so you'll have your upper limit, lower limit, okay? Let's see what you get. Right, you can pause it or go along with it. Make sure it all matches up. And look, see the answer we're getting. So 11.76. One eye back to the question. Does it say anything about decimal places? Nothing. So 2 place a decimal then. Don't forget your units. Okay. Question 10b, part 3. Find the work done by the pull on the rope when the mass has been raised by 15 meters. Okay. Now, so the work done, so in this situation is the change in kinetic energy, right? So half mv squared, so the change in kinetic energy, right? So your half mv squared, again, invisible, hence, I need to apply that, right? So you mightn't be unsure, or you may be trying to figure out how the hell do I go about that. Use your maths instinct, right? I need to apply that, find the work done. Okay, so the change in kinetic energy. So the mass there is 9 kg. Using that value there, look. So you're bringing the mass being raised by 15 meters. Initially, the mass is at rest. Okay, so no kinetic energy. Go back again, look. So initially, the mass is at rest. Okay, now everything in a question 10 in all questions in applied maths, they're not telling you for the fun of it. Okay, it's there to help you figure it out. So if you find that you get an answer and you go, look, oh, 137.2, no, I didn't use that, no, then we're in trouble. Put the pen down and, take 2. Everything has to be used. All right, so keep that in mind. So work done, change of kinetic energy. Don't forget your joules then, and Shine. Okay, I'll talk to you soon. Hope that helps.